We've all we've all dealt with the limitations of copper cabling, right? I mean, if you try to push a high bandwidth video signal, especially DisplayPort, past a certain point, physics just says no.
Yeah, it really hits a wall. And with DisplayPort 1.2, that copper cliff comes up incredibly fast.
You get those weird sparkles or just a totally black screen.
Exactly. I mean, we are talking about pushing 21.6 gigabits per second. Copper simply doesn't have the shielding or the conductivity to maintain that kind of throughput over distance without massive attenuation.
Which brings us to our deep dive today. We are looking at the Kramer 612 RT. We pulled the specs on this transmitter-receiver set from HDTV Supply. And the big headline here isn't just that it extends the signal.
Right. It's the uncompressed 4K at 60 hertz.
Up to 200 meters.
Yeah, 656 feet. And to bridge a gap that massive with that much data, Kramer basically had to ditch copper entirely. They went with a completely different transmission medium.
Right, they used fiber, specifically dual LC multi-mode OM3 fiber.
Which makes perfect sense here. OM3 is really the sweet spot for this kind of range. You avoid the high cost of single-mode transceivers, but you get so much more bandwidth headroom than older fiber standards.
It effectively decouples the signal quality from the actual distance. With copper, your signal-to-noise ratio drops with every single foot you add.
But with this fiber setup, the signal at meter 200 is virtually identical to the signal at meter 1.
And that's a huge deal for data integrity because, usually when vendors claim 4K support on these extenders, there is a catch.
Oh, there's always an asterisk.
Right. They compress the color space down to 4.2.0 just to save bandwidth.
Which is fine if you're just watching a movie, but it is a total nightmare if you are looking at text or CAD drawings.
You get those weird colored halos around fine lines. But looking at the 612 RT spec sheet, it explicitly lists 4.4.4 chroma subsampling at 4K 60 hertz.
That is the critical distinction. It pushes 5.4 gigabits per lane, so you get full 4.4.4 color depth. So if you're, say, a radiologist examining an X-ray or an air traffic controller looking at high-density radar data,
pixel-perfect accuracy is non-negotiable.
Completely non-negotiable. And this unit delivers that raw, uncompressed feed.
Now, speaking of those high-stakes environments, the source material also highlighted pure fiber connectivity for secure applications, which comes back to the physics of the medium, right?
It does. In high-security setups like government facilities or financial trading floors, copper is an active liability, gives off an electromagnetic signature.
So someone could theoretically sniff the data.
With the right equipment outside the room, yes, they could read what is running through the wall.
But fiber is just photons. There's no RF leakage.
Precisely. It is electrically isolated, unless someone physically splices into the glass line.
Which breaks the connection instantly.
Right. You just can't monitor it. For anyone dealing with classified or sensitive IP, that physical layer security is a massive selling point of the 612 RT.
It effectively air gaps the display from an RF perspective. Plus, it supports HDCP 2.2 for content protection and DPCP.
And it passes EDI data.
So your computer actually knows what monitor is hooked up 600 feet away. It doesn't just default to some generic safety resolution.
Exactly, as a transparent bridge. And despite all these heavy specs, the hardware itself is surprisingly low profile. It is not some bulky racked mount box.
No, it's just a pigtail form factor that plugs right into the DisplayPort connector, which is great for installation density. If you have a workstation with 4 monitors, you don't want 4 massive converter boxes cluttering up the desk.
Right, they just hang off the back of the GPU and the monitor. And they handle power really well, too. They take micro USB, so you can often just pull juice directly from the source device.
Or use an external supply if you need to. And I noticed it supports dual mode DP or DP++, so you have flexibility if you need to adapt to HDMI on the receiving end.
It really facilitates a shift in how we structure workspaces.
Think about it. If you can put the actual workstation in a climate-controlled secure server room way down the hall, but the user experience at the desk is exactly the same as having the tower at your feet.
That is exactly where the industry is heading. Centralized computing with remote visualization. You remove the heat and the noise from the user's desk, leaving just the interface.
It really makes the concept of a personal computer feel a bit physical.
How so?
Well, if the 612 RT removes the latency and quality penalty of distance, maybe the future isn't about where the computer actually lives. If uncompressed data can travel flawlessly over fiber, Maybe our desktop monitors will eventually just be windows into massive centralized computing farms miles away, completely untethered from a local machine.
We might just be moving toward a world where the desk is just a piece of glass and a very, very long optical cable.
Definitely some food for thought next time you sit down at your desk.
Yeah.
Thanks for joining us on this deep dive.